Hello, today I'll be teaching you the physics of throwing a frisbee. First, I'll be showing how to throw a frisbee backhand. First, grip the frisbee in your dominant hand. Put your thumb on top of the frisbee and wrap your index finger around the rim of the frisbee and curl in your last three fingers. Flick your wrist and let the frisbee flow off your fingers while extending your arm, like that. Another physics field that applies to a frisbee is the effect of forces. There are three forces that affect a frisbee's motion: the force of lift, the force of drag, and the force of gravity. A very important detail is that the greater the exposure of surface area, the more the force will act upon the overall object. So, first, the force of drag is friction in the form of air resistance, and it slows down the frisbee horizontally. As air friction encompasses the object enduring it, to minimize drag, you should minimize horizontal surface area. If you look at this diagram, this frisbee thrown at a 90-degree angle is only affected by air resistance at this one point, while the frisbee thrown at a 45-degree angle is affected by air resistance all throughout its diameter. In a real application, you want to throw a frisbee at a 90-degree angle perpendicular to your body, and if you do this, the frisbee's angle will be flatter, and less surface area is exposed to air resistance, allowing the frisbee to be slowed down at a lesser rate. Next is the force of lift. Lift is the force that counters the force of gravity, allowing the frisbee to stay in the air longer. Because of a frisbee shape, which is called an airfoil cross-section, the airflow above the frisbee travels faster than the airflow below it, creating lift. To increase lift, a frisbee should be spun at a greater rate to have greater angular velocity. If you look at this diagram, this non-spinning frisbee causes torque to push the front end of the frisbee up, minimizing the amount of lift that can be acted upon the frisbee. Meanwhile, this spinning frisbee is constantly spinning, which has a constant amount of surface area exposed to the force of lift, which keeps it stable. Finally, gravity is the force that pushes the frisbee down to the earth. Because of the force of gravity, the frisbee eventually hits the ground at the end of its flight. One aspect of physics that directly relates to how a frisbee flies is the conservation of angular momentum. Due to a concept called gyroscopic precession, the more angular momentum an object has, the more stable it flies. This is because an increased angular momentum resists torque from forces acting upon the object perpendicularly. In this case, these are the torque from gravity and the torque from lift. These torques end up countering each other and will lead to a flat flight, which is stable as long as the frisbee continues to have angular velocity. If it's thrown correctly, a frisbee will have negligible external force and torque, and therefore will not lose angular momentum. This conservation of angular momentum allows the frisbee to stabilize itself during its flight because the angular velocity of the frisbee keeps the frisbee wanting to continue spinning in the same direction. To calculate angular momentum, you have to multiply the moment of inertia of an object times the angular velocity. Because of a frisbee's abnormal shape, which is called an airfoil, the total moment of inertia is the moment of inertia of a hoop plus a disc. I used displacement to calculate the ratio of hoop to total frisbee, and given the mass and radius of the frisbee, I was able to find the two separate moments of inertia and add them together to get the total moment of inertia of the frisbee. Using the moment of inertia I found, I can find the total angular momentum of a frisbee during its flight based on the amount of angular velocity or spin applied when it's thrown. By finding the amount of angular velocity of the frisbee, you could tell how stable the frisbee is flying. Based on the physics concepts that I covered, there are a few tips to improve your frisbee throw. First of all, you want to position the frisbee at a 90-degree angle perpendicular to your body. If you do this, the surface area exposed to air resistance is minimized, so it will take longer for the frisbee to be slowed down. Also, you want to give the frisbee as much angular velocity as possible by minimizing the distance between the torque and the frisbee. If you throw the frisbee with your arm, the source of torque is your shoulder, which has a radius of the length of your arm. To minimize this radius, you want to give the frisbee angular velocity with your wrist. By flicking your wrist is the main source of torque on the frisbee, and the length of your hand is the radius. Using these concepts of throwing the frisbee horizontally and flicking your wrist when throwing, your frisbee throw will be much better than before.